Hello, calling all future tech wizards. Yep, all future tech wizards I'm calling. So, hello there. My name is Daniel Bullen, and welcome back to my channel, Learn Computing with Daniel Bullen. So you can join me on a journey through the depths of the Unit 1, Paper 1 of the Edexcel iGCSE Computer Science paper. So, in that one, we are going to unravel complex concepts, decode tricky questions, and arm you with the knowledge that you need to ace those exams of yours. So whether you're a seasoned pro at this or don't have a clue, this video is for you to watch regardless, as it will be your passport to your dream success. So hit that subscribe button, grab your virtual notebook, hit that notifications bell, and share this video and channel far and wide, and let's embark on this epic adventure together. So, let's look at the first question. So, computer systems have both hardware and software components. So the central processing unit uses a fetch, decode, execute cycle. So we need to state what is meant by the term program instruction. So the answer you could have in there would be an action that is carried out by the CPU. That's literally 1 mark. Or you could say something that tells the CPU device what to do. Or you could say an operation that will be executed by the CPU. Any of those will get you 1 mark. Okay, next one. State what is meant by the term memory address. It's a pointer identification of a location in memory. Or you could say it's a pointer location where data will be accessed from and stored to. That's 1 mark. Okay. So now what we need to do on part B is identify the component of the CPU that provides temporary access storage. So it's not going to be the address bus, it's not going to be the data bus, and it's not going to be the control unit. So the component that provides temporary data storage is the register. Part C, performance of the CPU is affected by the clock speed, so we need to give one other benefit. So there are several, but we only need one. So you can have more instructions can be carried out per second, processes run faster, programs are executed faster, and you can run more complex programs. So any of those benefits will get you 1 mark. And on part 2 of part C, we need to give one drawback of having a higher clock speed. So it needs more power, the CPU could become unstable, the CPU could overheat, and more cooling is required. Any of those will get you 1 mark. It's literally copy and paste a mark scheme. Okay, so what we need to do now is identify one of these that describes a sequential computational model. So it's not going to be A, it's not going to be B, and it's not going to be C. Because C describes a parallel computational method, B describes a multi-agent computational model, and A describes a method of accessing data from secondary storage devices. So it's not any of those, so it's D. Okay? And now we're on part E. Part 1. So a program can be written in a high-level language or a low-level language. So we've got to give one reason, just one reason, for writing a program in a low-level language. Well, you can have any of the following, but just one. So when fast execution of a program is essential, that's 1 point. You would need a low-level language when you're writing code to control a device. You would need it to make efficient use of a device's limited storage, and you would use low-level languages when writing code for a particular architecture or an embedded system or a hardware. So any of those, that's 1 mark. Or you could just say when writing code for a particular architecture. Keep it simple. Right. On with part 2. State the purpose of the assembler. The assembler will translate assembly language into machine code. That's literally it. Purpose of an assembler will convert assembly language into machine code. Bosh, done. Okay. Part 3. Complete the table by adding 1 tick in each row to match the description. So, the interpreter will translate the program each time it's executed. The compiler will produce a permanent object code. An interpreter will translate line by line, whereas a compiler will translate the whole program before it's run, and a compiler will generate a list of errors once a complete program has been translated. So that will be where you need to tick the boxes, which is how you will get those marks. So let's say I want to highlight, which I can't highlight in this PDF, but A. So let's say I want to add a line here. That is where you would be ticking the boxes. So if you tick them in there, in those boxes that I've just highlighted, I just put a line through, that's 1 mark. That's 3 full marks there. Okay? So that should be fine. On to question 2. So this is something they have to ask. They've got to ask this. So, computers use binary to represent and store data. Binary number 78 is ASCII code for the character N. So we've got to convert 78 to 8-bit binary. So, I would do 128, 64, 32, 16, 8, 4, 2, 1. 78. So it's not going to be that. It's going to be a 1. 64 can go into it. 32. It's not going to be 16. 16 and 8 is 72. Plus 4 is 76. Plus 2 is 78. So 78 is 0, 1, 0, 0, 1, 1, 1, 0. Bosh, done. That's literally it. It's literally primary school maths. So you're basically saying 64, add 8, add 4, add 2, 78. Bosh, done. Right, on with the next one. We need to identify the number of characters that can be represented using standard ASCII. Process of elimination here. So think of it as like Hell's Kitchen or The Apprentice. Right, so it is with regret. A is not correct because ASCII uses 7 bits. 64 would need only 6 bits. So it is with regret. A, you're fired. Right. C, that's not correct. ASCII uses 7 bits. 256 would need 8 bits. C, you're fired. D, not correct. 512 characters needs 9 bits. You're fired. So, who's going to be my business partner? B. B is the correct answer. Bosh, there you go. Alright, next bit, we need to explain one reason for using Unicode rather than ASCII to encode languages other than English. So it's a 2 marker, so you need a bit more effort. So, all of the major languages can be represented by Unicode. That's 1. Because it uses a minimum of 16 bits. That's literally it for 2 marks. You could also have Unicode can represent all languages, all the characters in any language, whereas ASCII can only represent English, Latin, and 128 characters, which isn't enough characters. Or we could say Unicode can represent all characters because it uses 16 bits. Done. So that's literally it there. Okay, let's move on. We must move on. We will. So we need to convert the denary number -43 to 8-bit binary using sign and magnitude. So we're going to put the sign here, then 64, 32, 16, 8, 4, 2, 1. As it's a minus, we're just going to have a 1. Not going to have a 0. We have a 1, 0. 32 and 8 is 40. 42, 43. As it's a sign, -43, -43 is going to equal 1, 0, 1, 0. 1, 0, 1, 1. That's your sign of magnitude. So you'll get 1 mark for adding 1 as the most significant bit, and then another mark for the rest of the pack. That's literally it for sign of magnitude. Nice and easy. Nice and easy. My favorite way of doing negative numbers in binary. But let's get to another question that they got to ask. You need to complete the table adding 2-bit binary integers. So this one is going to be slightly more difficult. So the way we do it is this. So following the rules of binary addition, first one's going to be a 0. 0 and 1 is a 1. 1 and 1 is a 0, where we will just carry the 1. Okay? Carry the 1. And then the next one, that's just going to be a 1. And then 1 and 1, that's going to be a 0. And then 1 and 0 here, that will be, because it's carried a 1, and all that, that will be a 0. And 0 and 0, and 0 and 0, we've got 1. And then we've got 0 here. So we can check it by converting each of those into denary. So we've got 16. So we've got 32 and 16 is 40. Not 40, 48. Plus 4 is 52. So that's 52. And then we've got 16 plus 4 is 21. So it's 52 plus 21 is 53. Hang on. 32 plus 16 is 48. Plus 4 is 52. So we got 52 here on the top. And we got 16 plus 4 is 20. Plus 2 is 22. So 52 plus 22 is going to give you 74. So 64 plus 8 plus 2. 74. So that is 74 in binary. So that's one way to check it if you're not sure. Moving on. A bitmap image is made up of 5 colors. So we need to complete the table by adding a unique binary pattern for each color. So for green, it's going to be 0, 0, 0. For black, it's going to be 0, 0, 1. For white, it's going to be 0, 1, 0. For red, then we're going to have 0, 1, 1. Then for blue, it's going to be 1, 0, 0. So you can see that each pattern is starting to go 1, 2, 3, 4. So we are literally going up each number as we go along in this binary pattern as our minimum colour depths. If you do something like that, that's 2 marks. Okay, so another image is 3,579 pixels high and 6,128 pixels wide. So, image is stored with a 32-bit color depth, and the metadata for the image is 732 bytes. So we need to construct an expression to show how the file size in megabytes is calculated. We don't need to do the actual calculation. So this is 4 marks. Okay? So, one of the expressions I would do if I was doing this, I would be tempted to have, in brackets, 3579 times 6128, and then times that by 4, and then add 732, and then divide that by 1,000 times 1,000. That's one of my possible solutions there. Or you could just have 3579 times 6128 plus 32, and then we could divide by 8, and then divide by 1,000 times 1,000. So if I was doing this, I would just do that. I would do the first one instead, because we're basically saying 8 times. So 3579 times 6128 times 4, brackets. And then plus 732 divided by 1,000 times 1,000. That is how I would say it. If you want to break it down more, you could do 3579 times 6128 times 32 divided by 8 plus 732 divided by 1,000 times by 1,000. Any of the 3 ways will get you 4 marks. So you don't need to do the calculation. So if this is one of those, if you get the mathematical mastery, you're laughing. Right, let's move on. Alyssa is a music producer. Figure 1 shows the denary values for 5 samples of analog sound using a sample interval of 0.2 seconds. So we've also got the table and we've got its graph. So we got to complete the graph using the sample information from figure 1 to show the digital sound wave. So let's also do a rectangle. So the first one's going to be a 1. Second one is going to be a 10. Third one is going to be 11. $12 actually. That's actually going to be a 12. So we've done 1, 10, and 12 as in a table. And then the last 2 is going to be a 5, followed by a 3. So that is how we would draw out the chart. So 4 conversions are plotted at the correct amplitude. That would give you 1 mark. Correct start points, that's 1 mark. And digital sound wave drawn using the candidate's plots, that will get you 4 full marks. So it's 3 full marks. So we've completed that. So what we need to do is give a suitable label for x-axis, I would say time, because that's in seconds. And then give a suitable label for the y-axis. I would say something like amplitude or meters. I would just stick with amplitude for this one, because 5 samples of analog, so we got seconds. I would definitely say time. And then up here, I would say something like amplitude. Okay, next one. Alyssa uploads music files to her cloud storage. She compresses the files before she uploads them using a lossless algorithm. So you give one advantage of using lossless rather than lossy algorithm for that purpose. So transfer times would be longer. You could also have larger file size, means less compression, takes up more storage space, and uses more of a data allocation. So those are the disadvantages. So I would just say larger file size, or I would just say takes up more storage space. Keep it simple. Part 2, explain one benefit to Alyssa of storing her music files in the cloud. So I would say storage capacity can be scaled up and down, so there's no need to buy more secondary storage. That's 2 marks there. Or you could say we'll have files all in one place rather than scattered across many secondary storage devices. I would just say storage capacity can be scaled up and down, so you don't need to buy more secondary storage. Okay, third one, we need to give one possible security issue associated with storing music files in the cloud. Storage hosts can be targeted by hackers. Alyssa has less control of her files. Or you could have files could be intercepted during upload. And it's reliant on the storage provider for security. So I would say storage host could be targeted by hackers. Okay. Next one, we got one of Alyssa's music files is stored at this web link. So we need to complete the table by adding a description of each URL component. HTTPS, that's protocol, 1 mark. Next bit, that's the domain name, that's 1 mark. RE12, that's the folder. That's the folder and directory. And then the last one, that's the file name. File name, boom. Mention those, 4 marks, bosh, done. Okay, fourth question. Reba likes writing programs. She's writing a guessing game. She needs a flowchart to show the logic of the game. So these are the components needed to draw this flowchart. So we need to draw it for the algorithm in the box on the next page, using each component once. And I mean only once. So do not add any additional comments. Use as many arrows and yes and no labels as you feel required to. So there's our flowchart. So in it, yeah, this is my awful one. You would have to draw it. So that would be like a start. So that'd be like a start. Then we go down. Then we go down here. Yeah. So this is how you could do it. So you got your start and you got your stops. And then we've got number is equal to 10. So they need to get the guess. And then the decision, right, is that equal to the number? If it's not, then it's going to go in a loop, make them guess again, go around until they guess the right number. Once they press 10, go into this part, we get this output, and then the program stops. So, if you have all of those, that's 5 marks. Start and stop terminators is 1 mark. Number set to 10 and get the guess, that's 1 mark. The loop will get you 1 mark. Yes and no labels, that's 1 mark. And connected to that image, all of those connected together correctly, that's 1 mark. I would have tried to draw it myself, but I'm terrible at drawing in PDFs. So, next bit, we need to identify an alternative method for writing an algorithm. That would be program code. Revo wants to develop a program that will convert the temperature in Fahrenheit to Celsius. So we've got 4 steps, and they're not in a correct order. So we need to give the letter of the step that initiates the value. So it's going to be D, where we set the temperature. And then we need to give the letter of the step that inputs it. So that's going to be B, where we're getting the temperature in Fahrenheit. All right, let's go down. 4C. Figure 2 shows pseudocode from an early version of an algorithm that Revo has written for another game. So the algorithm asks the user to input a color or input, -1 to end the game, award 1 for red, 8 points for orange, generates a score for the game and displays the results. So this is the pseudocode we need to go through. So we've got all these variables set, and going into the while loop while it's not -1. So it's going to go into the color, ask the user to enter a color if it's a red, 1 point else if it's orange, set to 8, and then we're going to set the score to red plus orange, then we're adding the whole score together, outputting how many reds, how many oranges. So what we need to do here is we need to complete a trace table to show the outputs, which is a hard one. So all of that's 0. So red pointer is going to be a 1. Orange is going to be an 8, meaning the num oranges is going to be a 1. Back into red, let's say it's a 2. And then another red being a 1, 2, and then a 3. Another orange, that's going to go up to 16. And then a num oranges is going to be a 2. -1, the score will output the score being a 19. Okay, so putting those in there together, making those columns correct, that would be 2 marks. And then the next bit we will need is where we are going to add everything else here. So score is going to be 19. Reds will be a 3. Oranges will be a 16. Okay? And that is literally that. Right, so give the line number of pseudocode that contains an error. If we go back up, it's line 23. And then the reason being, the replacement line you could have for 1 mark, it will be send number of oranges and num oranges to display. So that would be the replacement line that would correct that error. Okay, that's that done. Number 5. Visa Health Centre is located in the northeast of England. The health centre uses AI to provide a symptom checking service for its patients. Patients log into the website and input their symptoms. So we need to describe how artificial intelligence could identify what is wrong with them. 2 marker, so you could say it will interpret patient input to identify symptoms and match the symptoms to possible illnesses. So that would get you 2 marks. Or there's more stuff you can add here. So that will also get you 2 marks. Or you could have this, will get you 2 marks. Or you could have this bullet point, will get you 2 marks. So they're asking you same question, it's just copy and paste the mark scheme. Okay. Next one. Give one reason why a patient may not want to use this online service. They might not have access to the internet. They might not want to use it. They may not have the technical knowledge to use it. Might not have access to a device. May want a real person. Can't take physical measurements. Hacking or security. May not want to disclose personal information or have a physical disability that stops them using the service. So I would say may not have access to the internet as one. Or I might not want to use it. I would just say may not want to use it. Okay, so the health centre has clinics in 2 buildings. The network server is in the Cleveland building. So name the type of network used to access a server from within the Cleveland building. It's a local area network. And then name the type of network to access the bill from the Stockton building. Wide area network. Okay. 5C. The network is at risk of an eavesdropping attack, so we need to identify a description of eavesdropping. So eavesdropping is intercepting information as it's transmitted over the network. So that would get you 1 mark if you tick that box there. D. Doctors use laptops when they visit patients in their homes. The laptops have solid-state drives. So state 1 reason why a solid-state drive is better than a magnetic hard drive for laptops. Solid-state drives are faster, so can access data much more quickly. You could say solid-state drives use less power, so battery will last longer. Solid-state drives are smaller, thinner, and lighter than a device that's a hard drive, so it's easier to carry more portable, and laptops have less room for them in drives. You could say SSDs are robust and they're quieter than because it doesn't allow any moving or mechanical parts. But for simplicity, I would just say SSD is faster, so it can access records more quickly. Done. Okay, 2 marks. Describe how data is stored in a solid-state device. I would say flash memory chips are used and and data is stored in blocks and pages. That is what I'd literally say. Flash memory chips are used and data is stored in blocks and pages. 2 marks. Okay, 5D part 3. The laptops have 2 types of memory, so we need to complete the table with 1 tick to match each description in the type of memory used. So it stores the boot up sequence, that's ROM. The contents are lost when a laptop shut down, that's RAM. If you remember that, that's 2 marks, bosh, done. Number 6. Santiago manages a computer network for small businesses. Networks are based on a topology, and figure 3 shows a network topology, and we've got to explain 1 benefit of this topology. So this is a ring topology, so you can transfer data quickly as data flows in 1 direction. You could say there's no need for a server or switch because the packets don't have to be directly routed to a specific device. Every workstation gets equal access to resources because each station has to wait until it gets a token. Or you could say it's easy to find faults. All of the tokens will end up on 1 workstation. Or you could say cheap to set up, uses minimum cabling. If I was answering this question, I would say it's cheap to set up and it uses minimum cabling. Done. Next one. Internet is the world's largest mesh network. Explain 1 reason why a mesh topology is essential for the internet. That's because it enables it to span a huge geographic area because additional nodes can be added to expand the coverage. Or you could say it can handle high volumes of data traffic because the data can travel via multiple routes. Or it needs to be scalable as mesh topology allows it to be decentralized with other nodes around them. So I would say it needs to be easily scalable as mesh topology allows this as it's decentralized with other nodes around them, as it's decentralized. So that is what I would say. So if I was doing this, I would say it needs to be easily scalable. Mesh topology allows scalability as it's decentralized. So that is how I would word it. Okay, let's go to B. Santiago works on his laptop whilst traveling by train. There's free Wi-Fi connection on the train, but Santiago doesn't use it. He prefers to set up a network between his smartphone and his laptop to connect. Name this type of network. It's a personal area network. Explain one advantage for Santiago of using a network he is set to connect to the internet rather than the free Wi-Fi. But faster connection speed because of fewer users sharing the connection. One bleeding obvious mark. Another one you could have would be improve security because it uses a secure cellular data connection. If I was saying this, I would say faster connection speed because fewer users are sharing the connection. Done. Simple. Simple there. C. Santiago uses audit trails to help protect the network. What is an audit trail? So an audit trail is a record of activities taking place on a computer system. Or you could say automatic record of what has happened and who did it. So I would say an audit trail is an automatic record of what has happened and who did it. Then for part 2 of part C, so we need to give one way the data from audit trails can be used to help keep the network secure. So there are a couple of ways. One's to increase accountability. Another one's to trace a problem back to its source. One is to find out if other users are using unauthorized application. And one is to identify suspicious changes. So I would say to increase, if I was doing this, I would say increase accountability. Okay, so we've got Santiago wants to find and fix the network vulnerabilities before the reputation of the company suffers. So we need to discuss methods he can use. Ethical hacking, commercial analysis tools, and review of network and user policies. So this one is an essay type question. So if you don't put anything, you're just going to get big fat 0. Yep, but we don't want that big fat 0. We want to get the big one, the 6, the big one, the beef, the Moby Dicks. You're in that exam as Captain Ahab going after those Moby Dicks, those whales that can feed you for a lifetime. So we could say, so discuss the methods. So we should consider ethical hacking. So I would start with ethical hackers are white hat hackers, whereby they attempt to access the network in the same way as a black hat hacker does. Ethical hackers won't attempt to steal data, but look for weaknesses in the network to point out to the organization. The white hat hackers will then fix the weaknesses and then you might want to say that ethical hackers can be employed by businesses to do that, plus do penetration testing, which is also called pen testing. And then using software to find weaknesses. So you could say the software they use could be configured to find a range of weaknesses, with results reported to the relevant staff of any faults identified. And then I would say, after fixing up the weaknesses, the organisation can then update their collection of rules and guidelines that govern behaviours of network users. The reason for continual reviewing is because users may not always comply with new laws and regulations. So in essence, reviews should be routine, should become a routine procedure. So something like that. So I've tried to demonstrate a comprehensive knowledge and understanding by selecting all of the relevant knowledge and understanding of the key concepts and principles of computer science to support the discussion being presented. The discussion will show a well-developed, sustained line of reasoning, clear, coherent, and logically structured. So that is what you will need to get a level 3, where you can get 5 to 6 marks. So that's where we want to be. If you had adequate knowledge and understanding of the key concepts, with some linkages and lines of reasoning with some structure, you can still get 4 marks. You won't get them all, but you'll get 4, up to 3 or 4. So if we can get to at least 3 or 4, that will put you in good stead. But if you can get 5 or 6, that's even better. That's kushti, in fact. So we have gone through all of those questions. So that is the 2022 Paper 1 Edexcel iGCSE Computer Science. So let's see if there's any more questions. No, there is not. Yep, there isn't. Yep, so there's no more questions after that. And there you have it. A comprehensive walkthrough of the iGCSE Computer Science Theory paper from 2022. So, like with the programming one in paper 2, paper 1 will require just as much practice as practice makes what? Perfect. So, call to actions. Grab some past papers and give it a go. If you found this video helpful, don't forget to hit that like button and that subscribe button and share it with your fellow students, fellow coders alike. Subscribe for more content like this. And as always, happy coding and thank you for joining me today on Learn Computing with Daniel Bullen. Until next time, keep practicing, keep exploring, keep coding, and keep being awesome. Bye for now. So please be sure to hit that like. And please also remember to hit that subscribe button. And another way to subscribe is to just click on this link, which is below each video I place. And if you like my content and you want to find out more about what I do, I've also got an online course called Introduction to Computer Systems on the Udemy website. So you just need to click on it. And there we go. So this is my online course, Introduction to Computer Systems. So this is the landing page for that course. So in it, you will learn. So these are some of the things we'll learn, like explaining the role of the central processing unit, describe the components of the CPU, provide an introduction to assembly language, which is low-level programming, explain the factors that affect the performance of the central processing unit, and I've also put in another bit that I'm interested in, the physics of overclocking the CPU, which made me develop an interest in electronics and also physics. So there's a lot more to it than even we realized. So this is the course content. So you've got computer systems, so I'm introducing you to it. Then I'm going into the different forms of architecture and assembly language. Then I'm going into the factors that affect it and the physics of overclocking the CPU. And then I'm going into logic, so combinational logic systems, making the logic gates, sequential logic systems, semiconductors. Then I go into all things binary, where we introduce you to number systems, all the way down to doing binary and sound, images and text. And then finally we got input and output devices and the different forms of storage, so that's where memory will come in. And then my assessment is basically one big quiz of 30 questions. So you don't need any knowledge to do this course. All you need is a computer with stable internet connection. So that's all you really need there. And why you should do the course? Well, wherever I don't know, I'll go out and learn it. So the way my brain is wired is I'm on the autism spectrum. So it will be an asset in helping you get through the online courses that we provide. So we understand how to explain things in simple terms due to my teaching background. So you could think of us as a real-life version of, say, a Sheldon Cooper from Big Bang Theory, minus the rudeness, or a C-3PO, but without the glitches. So I'm on the autism spectrum, so we're on the autism spectrum and have a rough idea on how to talk to them and relate to them. And my teaching style is that style I've crafted and one that works in a way that some people don't get if they only had tuition in the classroom or just want to study the subject a lot more. So this course provides you with the opportunity to go further than you would in the subject that you want to pursue. So those are some of the reasons why you should consider buying this online course, because once you buy it, it's yours for a lifetime. For some of my videos, I will go through programming tasks. So if you want to do these yourself, I have put a Replit link below on my programming videos. So you just click on REPL, and this is what you need if you haven't signed up at all. So you just click sign up. If you've got an account, you just click login, and once you've logged in or signed up, this is the page that will appear. So if I was to log in right now, this is the page, so this will appear. So that will be the page there. And in addition to all that, I am also a private tutor where I offer my private tutoring services specializing in ICT and computer science. And I look forward for you coming to me for lessons. Goodbye for now.